record, share. All right. Let's go here. Okay, so I recognize that some of us are freshmen, some of us are in our essentially junior, senior years, so we have different experience with writing. So I'm gonna help you all learn how to find science articles and how to cite them for our class and for any other class that you're gonna do. So as far as finding your references, your resources for your paper that you're gonna write, you're gonna go to my.canvas, and then you'll see this link launcher. You're gonna click on the library link. The library link will take you to this page. You're gonna go to the databases, A to Z. Within A to Z, you're gonna click on the P letter. What we're looking for, you're gonna scroll down in that list of P, and you're gonna find PubMed. When you click on PubMed, it's gonna take you to a website that looks like this. You're gonna wanna be logged into the library, so when you click that library link, make sure in the top right corner you're logged in with your information. That'll give you access to all of the articles, just about all the articles. Anything that the university has paid a subscription for, you'll have access to through this database. And this is just a link to the website, but again, if you go in through the library, you'll have more access than if you just click this link. And then there's also scholar.google. This is an academic search engine on Google.
Now, we do not have to use those two things. We can use other outlets, correct? Because I took a medical research class, so I know where to get articles, and so I do not have to necessarily just use those two, correct?
Correct. You don't have to use either of these two specifically. These are just two ways that you can find things very, very easily. If you know where to get them, then they'll probably, whatever article you can find is probably going to be on PubMed. If it's on PubMed, it's going to be on Google Scholar. It's Google, right? It's got everything. So yeah, if you know how to find it, then do what you know. If you have trouble, then I recommend these resources.
Okay. I will tell everyone that my medical research professor had said that medical articles, you definitely want to trust the ones that say .org or .gov. Sometimes the .nets are not up to date and correct with the latest information. Just pass
there you go.
that
Yep.
on.
If you follow something that's .gov, that's probably going to be your best bet. And if you'll notice that this PubMed, this is through the National Institute of Health, so the NIH, and so it's at nih.gov. So this is a very safe website. I definitely recommend you all check this out. Okay, so that's how to find your resources. Now we need to cite them. So you're going to cite them in the paper after you make a claim. And then you're going to make your bibliography where you have the full citation at the end. So there is a citation creator online. You can go and find these on Google. Type in the article name, the author, and it'll give you a citation. I did that my whole undergrad career, and then in grad school I found out how to use a citation manager, and my life is so much easier. So if you all have any sort of writing that you have to do in the future, I definitely recommend investing an hour into a citation manager over your break. So again, this is a link to the library.spalding website. Here's a phone number. You can call and talk to a librarian. She's really, really helpful. I talked to her yesterday.
I used to use one that's called citethисforme.com, and it works just fine. It's really great.
What is it? Stormy?
Citethisforme.com.
I'm sorry, can you spell that? Is it F-O-R-M-E for me?
Yes.
Okay, so that is one resource that you will have as well. And the library link that I did provide, it has some just quick internet websites you can use. But again, I recommend downloading one of these 3 free softwares. Pointer options, laser pointer. Either of these 3, they're gonna work about the same way. And you can search and download papers from these as well as use them as a citation manager. They work with Microsoft Word. So you type a sentence and then go into your headers in Microsoft Word, and then you can just import a citation, I promise. If you put an hour into learning this, you will get that hour back in saved time that you will have spent figuring out how to do a citation. This is worth your time. For our purposes, I'm really not concerned. I don't have a preferred style over one another. Yeah. Yep.
So our sources need to be like scholarly journals. It can't be any kind of like textbook article we pull up.
Pull something from a textbook, that's fine, but I would like for you to get some experience trying to read a journal article, some sort of an experiment or a clinical study. So something that's going on like right now, vaccine development, vaccine testing. It'd be good for you to just get some experience trying to read those. But yeah, if you want to cite a textbook, do that. Let's just avoid Wikipedia. If you use Wikipedia, then follow those citations and cite those. But again, you don't have to do this. I'm just trying to give you resources to help you in the future. All right, chapter 10. I'm not gonna lie, you all. It's really overwhelming. This is a chapter where even I felt overwhelmed going through this. This took me a long time. So, the biggest part of it is just drug names. Drug names are miserable to try and pronounce. You're gonna see me trip up on them a handful of times today, and they're hard to memorize. So I've tried to organize this material in a digestible way, and I'm gonna tell you what's more important and what's less important. Okay, again, for the focuses of our quiz, it's gonna be really big picture stuff. Don't worry about hardcore specifics today, and I'll emphasize what's important. Okay, so going back to all right, so he developed the concept of selective toxicity, which means that a chemical can target a certain infectious agent better than others. He found this because some dyes could stain certain bacteria, but they wouldn't stain others. So he's like, okay, well, if a stain is specific, maybe it can kill them specifically as well. So then a couple decades later, they developed this drug called salvarsan. And this was effective against syphilis. Syphilis is a bacterial infection. It occurs over decades in humans if it's not treated early. And this is a sexually transmitted pathogen. So I said a couple decades later, that applies to this slide here. So after Ehrlich developed salvarsan, there was a German scientist, Domach, I think I'm pronouncing that correctly, developed Prontosil. So it was a red dye, and it was effective against some gram-positive bacteria. These aren't hugely important. Again, I don't need you to memorize Prontosil. I don't need you to memorize salvarsan. But just understand that by paying attention to what happens in a lab setting, we can start to think about how we can deal with the natural world. So we see that a dye kills a bacterium, and now all of a sudden we think, wait, maybe I can create a drug to kill that bacterium, and then a different drug to kill that one. So we're getting the ball rolling. And then, I believe it was 1928, Alexander Fleming. So he had a culture of bacteria. You can see these little colonies here, these little spots, and it was contaminated with a mold. You can see the mold, the Penicillium, at the top, and then you'll notice all around this Penicillium mold, we don't have bacterial colonies. So then he isolated this mold and found that it produces an antibiotic. And then he called that antibiotic penicillin. All right, so if we're just talking about antibiotics, we can generally have a lab-created drug. We're going to call that synthetic. You make it in a lab. Your book lays out a hard and fast definition for an antibiotic being a drug produced from one organism that is going to kill another organism. I'm going to tweak this a little bit and call this a natural antibiotic as opposed to a synthetic antibiotic. An antibiotic as a whole will kill bacteria. It can be from an organism or designed in a lab. So we'll call it either synthetic or natural. But I do want you to consider a synthetic agent that kills bacteria, that is an antibiotic. And then we can have something kind of in between where we can take a drug produced from one organism and then alter it in a lab setting, and we call that semi-synthetic. So it's produced naturally, and then we adjust it to make it more effective. Semi-synthetic. All right, if most of us are going to work in healthcare, let's talk about dosages. A toxic dose of a drug is going to hurt the host. In our case, it's going to be humans. And so these dosages are going to depend on the drug that we're talking about, the age of the individual. Are they a man or a woman? Are they overweight or are they anorexic? All of these are going to play into a lethal dose. The concentration that's going to be effective is going to be the therapeutic dose. So it's going to be effective at getting rid of the pathogen that's going to cause a disease. So we can take these two together. If we divide the toxic dose by the therapeutic dose, we're going to get what's called the chemotherapeutic index. So let's talk about a test question. Do you want so if you're designing a drug, do you want a large or a small chemotherapeutic index and why? Just think about it. What would it be if it was 1? If the chemotherapeutic index was 1, what would that mean?
It would very specifically work in a very limited amount of cases.
Okay, so you're getting really close. I'm sorry, the person online, what did you say?
It said that it would have such limited efficacy because it would only work in such a small number of cases. It wouldn't be able to cover like a wide variety of cases.
Okay, so if by definition the therapeutic dose is met, then we're going to get rid of the pathogen. So it's going to be effective, but it's also going to hurt the host. So if you have a chemotherapeutic index of 1, that means that it's going to take so much of a drug to get rid of this pathogen that you're inevitably going to get hurt. That's a problem. We don't want that. So we want really high chemotherapeutic indices. So think about this. If you have a drug where the toxic dose is 10, it takes 10 volumes of whatever it is to hurt you, but it only takes 1 volume to heal you. That's good. There's a huge range there where you're not getting hurt. So you want a large chemotherapeutic index when you're designing a drug. That's important. I want you to know that.
Can you repeat that?
Yep. So with the chemotherapeutic index, we want the therapeutic dose to be really low relative to the toxic dose. If they're close, then that means that you're going to get harmed as you try and prevent further harm, right? You're trying to get a therapy, but you're going to get hurt. So what we want is the therapeutic dose to be really low relative to the toxic dose. So therefore, you're dividing a big number by a small number. So that's going to make an ideal chemotherapeutic index large. Yeah.
So if the toxic dose and the therapeutic dose is the same, wouldn't that mean that the therapeutic dose is toxic?
Yeah, exactly. So if this index was 1, then that would mean that the therapeutic dose is toxic. Exactly. And that's what I want you to see. That's a problem. So you want to design a drug that's effective at a low concentration, but doesn't hurt you until you consume a lot of it. But if we're designing drugs, you might not be able to figure that out. Okay, I'm going to include this slide a handful of times. I think this is really worth studying. If there's any figure in this whole chapter, this is one of the most important figures for you all to study for your exam. Just to understand categorically what is effective against what type of organisms. And so if you look here, we have these arrows that span across different groups of bacteria. We're going to call this the antimicrobial spectrum.